So in class together, I want us to look at questions 1, 3, 8, 9, 15, and 22. Hopefully we get through them by the end of the period. And then your homework to do is going to be these ones here. I tried to pick questions that kind of gave you a range of the year. I picked questions from all units 1A through 3B, ranging from polynomials all the way to polar. So we can get kind of some that good practice as we're going through. Now, as you're doing the MCQs, you should have your note packets out. If you do not have all 6 note packets with you, I would recommend that you get them from home and bring them with you over these next few review weeks, so you can use them and access them and review them. If you don't have them, you can use my review or my notes on Canvas. Also, I want to point out in this PDF, if you go all the way to the bottom, eventually get there. There we go. This is the last page. On this page, I have included the answers. So there is the answer key for all these questions. But what I want to point out even more is this column right here. This is where you can find it in your notes. So, very first question is 1.6. That is where we would find that information. Question 2, 1.1. Question 3, 1.11. So forth. I made sure I structured our notes based off of College Board's pacing and outline. So our notes will match up with what we have here. Okay? So, again, we're going to go to question 1, which is in 1.6. So as you're going through these on your own, you can pull up those notes, go to that location, and see what you can do with it. But let's go ahead. I want you guys to take a moment or two in your groups to think about this problem. What is it asking? And what you might be able to do if you have your notes. Maybe go to 1.6 or pull them up on my notes. Go ahead and take a couple minutes for that problem. All right, everybody, ready to go over it? Okay. So, polynomial function is given by p of x equal to that thing. Which of the following statements about the end behavior of p is true? Like I said, I also have that key concepts PDF under the review links that you could also use to reference end behavior. This is a polynomial. So end behavior of polynomials are based off of the first term. So negative 4x to the 5th. I want us to look at this. On each of these, they're talking about the leading term and the degree. Leading term, degree, leading term, degree. On each of these, the leading term is either positive or negative. Even if we didn't know how to do this, what is the leading term? Is it positive or negative? So, which two can we eliminate right away? A and C. Those are saying the leading term is positive, and it's not. Leading term is negative. So again, even if you didn't understand how to find the end behavior, it doesn't mean that there's not something you can't do. You can always find parts that you can do. Read through the problem, read through the answer choices, see what you can do. Next thing is to look at the degree. What is our degree? Even or odd? All right, is there another one we can eliminate? So we're looking at B. Degree is, all right, do those match? All right, so can we eliminate anything else? Unfortunately not. But at least we have it down to a 50-50. That's better odds than 25%. So, if you didn't know it from there, I would recommend you guess and move on. But at least you're able to eliminate. However, we can do this by remembering if we have an odd degree. Odd degrees are similar to cubic functions. There's a cubic function, or this cubic function. Which one do you think I would be? This first one or the second one? Why the second? Because of the negative. That negative causes us to reflect. So therefore, we are of this form. Now we're dealing with end behavior. So let's look at the end behavior. For the one I have circled, as x goes to negative infinity, where is our function going? Which one matches that? B or D? As x goes to negative infinity, the function goes to positive infinity. Does B have that or does D have that? Which one? B. We see that right here. As x goes to negative infinity, our function is going to positive infinity. We can double check the other side, but that is also true. As x goes to positive infinity, our function goes down to negative infinity, and that also matches with the right-hand end behavior. So, we can think through these problems. We know how to do this, okay? We just are refreshing and reviewing. This is why we have 4 weeks until the test, to make sure we go through these different types of problems, these different concepts, and remind ourselves of what we do. All right, next question I want us to look at is number 3. So please look at number 3. Number 2 will be yours for homework. I'm going to skip over that one for now. I want us to look at number 3. Now, down at the bottom, it tells us we'll find that in 1.11, which is true. But we also have the information. This is asking about zeros, vertical asymptotes, and holes. And I have that in 1.8 through 1.10 is where we find that information in our notes. 1.11 just continued, brought it all together, and gave us some further examples. Right around there. So if you have your notes, if you want to use mine, you go to 1.8, 1.10. See if you can remind yourselves of what we need to do. I'm going to give you one hint. You are going to need to factor the numerator and the denominator on each. Okay, I'm going to give you a minute or so to think through that problem, try it out. All right, let's go ahead and look at this. Let's start with A. What is the factored form of A in the top? What's my two factors? X what? Minus 3 and? It's minus 1, okay. And on the bottom? And? Now, I always like to look for holes first. How do we notice a hole? Exactly, when the top and bottom match. Do we have a match? What is it? The x minus 1. There's our match. That is going to give us a hole. Okay? What is the hole? 1. Remember, it's the if we were to solve it. So hole is x equals 1. Does that match with what they're asking for? Okay, so far A is good. Okay? How do we determine a vertical asymptote? The bottom equals to 0, whatever is not the same. So here's this one, x minus 2 equal to 0. What do we have? Does that match? Okay, and then how do we find a 0? Set the numerator, x minus 3 equal to 0. Does that give us x equals 3? So does A seem to give us what we want? Yes, it does, and it ends up being the answer is A. I would, just to be careful, double check the other ones. Often I don't trust if my answer comes out as the first one. I'm like, is it truly A? Am I good with that one? So I tend to like to be cautious and double check the other ones just to be sure I can eliminate them. But the answer does end up being A. So that gives us, again, the whole when we match. The top one is going to give us our 0. And then the bottom one is going to give us our vertical asymptote. Okay? Again, stuff we did. We've seen this. We've done it. We just need to remind ourselves. Last time we did rational functions was probably back in October. So it's been a while, all right? But again, we're taking this time to review and go over things. All right, next one I want us to look at is number 8. So go to number 8, please. All right, what are we dealing with at number 8? Logs. What unit is logs? 2b. We'll do that right now. All right, ladies and gentlemen. Are there any of the log properties that we remember? Maybe let's start with this. When we had multiplying in logs, what did it expand? What did that change into when we expand? Addition, right? Multiplying changed to addition. So there should be some addition between our k and our z. Which one does not have addition in between the k and the z? So can we eliminate d? Yes, we can. Okay? And again, you can just kind of go through that. And then we have division between the kz and the w squared. Do we remember what division turned into? Do each of those have subtraction here? Okay, so we can't eliminate. Here's our other property. What happened to the power? It moved in front of a log. Between these three, which one has a 2 in front of the log? So probably B, but let's go and work it out anyways. So we have log base 10 of k times z over w squared. I would, on this one, start with the division because that's in between the two kind of terms there. So that's going to be log base 10 of k times z minus log base 10 of w squared. Then, like we said, a multiplication becomes addition, and the power goes in front of the log. Now, I want us to pay attention to A. A has addition, and then the 2 came down. But they did not put it into the separate logs here. We should have addition between two separate logs, log of k plus log of z, and then the power comes in front of the log, not just in front of the w. Okay, so minus 2 log base 10 of w. Again, properties of logarithms we've seen, but even without working it out, we were able to kind of think about it and say, hey, there should be addition. All right, eliminate d. Oh, the 2 should be going in the front. Oh, that's only on b, so that should be our answer. So we're able to eliminate. But again, using our log properties as we see here. Which we've seen, we've done, we've did expanding, we did condensing, just like we see here. All right, the next one I want you to look at is problem 9, the one right underneath this one, with this graph. want you to read over problem number 9, look at the graph, look at the answers, think about, even if you don't know how from the graph to create an equation, are you able to eliminate choices or figure out a way to help you determine which one is the correct answer? All right, you've had some time to think about it. So I went ahead and wrote out the table of values here. You could have written them just as points. You could have said, okay, hey, this is 1, 8, this is 2, 4, 3, 2, so forth all the way down. This is geometric sequence. I don't know if we remember, but geometric relates to exponential, whereas arithmetic related to linear. All right, so any thoughts out there? Anybody did something that helped you maybe eliminate some choices? Now there's a reason why I wrote the table. These are the points. The function that is the one we want should have these as their values. So if I was to plug in these values, these should be my outputs. So even if you don't know from here how to get the equation, start plugging things in. Maybe start with 1, 8. Plug it in. See if it works or if it doesn't work. I'd start with the first one. So that would be 4 times a half to the 1 minus 2. What is 1 minus 2? Okay, so 4 to the 1/2 to the -1. What do we do when we have a negative power? Because this is, again, not a non-calculator. We should be able to do this by hand. What do we do with the negative power? We do the reciprocal. We flip it, right? So that becomes 4 times, really 2, because that's 2 over 1. Well, what's 4 times 2? Is that what we want? Yes. However, do not just automatically circle A. You need to eliminate the other ones. Check the other ones. There might be another one that also gives you 8, and if there is, then you would need to check a second point. So go through, plug in 1 to each of those. The ones that don't give you 8, eliminate. Once you're down, and hopefully it's down to 2 choices, then plug in 2 and see which one gives you 4. All right? So go ahead and keep going. Try that out. There are obviously other ways that we can think through this, but this is one way in case you don't remember how to do this problem. You do know how to plug things in and check values. That is something you do know how to do. Okay? So try it this way, and then we'll discuss other things. All right. Did we find any that we could eliminate? Did B give us 8 when we plugged in? Yes or no? No? Let's see, we can double check that. 8 times 2 to the 1 minus 1. What is 1 minus 1? What is anything to the 0 power? So 8 times 1, does that give us 8? So that one actually does work. Let's try the next one though. 8 times 1/2 to the first. Well, that's just half of 8. What's half of 8? Does that give us what we want? Oh, so we can eliminate C. 16 to the 1/2, 1 minus 1. Well, what is that going to be equal to? One minus 1 is 0. What's anything to the 0 power again? So 16 times 1 is, so can I eliminate D? Yes, we can. So this worked out. These did not. So then what do we need to do now? plug in 2. Well, let's do that. So this does require us to remember our exponential properties. 4 times 1/2. 2 minus 2. What is 2 minus 2 again? What's anything to the 0 power? And so, does that give us what we want? Yes, it does. And hopefully, let's double check the other one. So that'd be 2 minus 1. So that would be 8 times 2 to the first. What does that equal to? What's 8 times 2 to the first? Does that give us what we want? So what's our answer? 8. Now, I want to go over a couple other things before we end on this one. With exponential problems are of the form y times a times b to the x. Growth is when b is greater than 1. Is this growing? No. If we had known that, could we have eliminated something? Which ones have a b value greater than 1? B. So right off the bat, I could have eliminated b, knowing this. The other part is decay, is when b is between 0 and 1. So just knowing this, again, can help us eliminate right away. All right? Then from there, you could have tested 1 and been good to go. All right? Okay, you have those other problems that I've listed out in Canvas that I want you to try out for homework and practice.